In this video, I present you MotionBooth. If you go through their project page, it is quite interesting. For example, it is quite clear that project holds a lot of promise, but the code and weights are not available. So in this video, I'm just going to go through its theoretical implementation, and then once the code and weight are released, then I will see if I have the GPU. I'm going to show you the working demo, but for now let's go through some of the innovation which they are trying to do in this research. So all in all, it is a framework for animating customized subjects with only text, while providing you lot of control over both object and camera movement. This is best described by showing you some of the videos, and we'll come to the architecture later. So let's look at this video. So you see, in the first one we have this image of a cat jumping off the stairs. The text has been given, and you see the performance of Dream Booth and Motion Booth. Motion Booth is the last one in the second row, and you can see that the quality of image is quite good, really realistic. We all know that generating videos for customized objects such as specific scenarios involving a particular dog's type or appearance has gained research attention a lot. And by mean a lot, I mean really a lot. This customized generation field originated from text to image or T to I generation methods, which learn a subject appearance from a few images and generate diverse images of that subject. Following them, subject-driven text-to-video or T2V generation has seen increasing interest, which has found a wide range of applications in personal shots or film reproduction. Can you imagine your toy riding along the road from a distance to the camera, or your pet dog dancing on the street from the left to right? But rendering such lovely imaginary videos is a challenging task. It often involves subject learning and motion injection while maintaining the generative capability to generate diverse scenes. Also, one of the project video booth trains an image encoder to embed the subject's appearance into the model, generating a short clip of the subject. But the generated video often displays minimal or missing motion, which resembles a moving image. Let me show you one more example, as you can see here. This approach underutilizes the motion diversity of pre-trained T2V models. Another line of work fine-tunes a customized model on specific videos, and that requires motion learning for each specific camera or subject motion type. Their pipeline restricts the type of motion and require fine-tuning a new adapter for each motion type, which is really inconvenient and computationally expensive. And there are a lot of examples on the project page which you can see and check, like this one where MotionBooth has generated the video where a plushie is swimming around a coral reef, and look how realistic it looks. Similarly, look at this. On the left hand side we have this subject, we have subject motion, and then it goes with the camera motion. And then look at the generated video. Let me play it again. Very realistic. So the key here lies in the conflict between subject learning and the video motion preservation. During subject learning, training on limited images of the specific subject significantly shifts the distribution of the base T2V model, leading to significant degradation, for example, blurred background and static video. Also, existing method often need additional motion learning for specific motion control. So this project argues that the base T2V model already has diverse motion prior, and the key is to preserve video capability during subject learning and digging out the motion control during inference time. To ensure subject-driven video generation with universal and precise motion control, MotionBooth really holds a lot of promise because it can perform motion-aware customized video generation. The video generated by MotionBooth we already have seen. MotionBooth can take any combination of subject motion, and camera motion as inputs and generate diverse videos, maintaining quality on par with pre-trained T2V models. MotionBooth learns subjects without hurting video generation, capability enabling a training-free motion injection for a subject-driven video generation. First, during subject training, they introduce subject region loss and video preservation loss, as you can see here, which enhances both subject fidelity and video quality. In addition, they have presented a subject token cross attention loss to connect the customized subject with motion control signals. During inference, they propose training-free techniques to control the camera and subject motion. They directly manipulate the cross attention maps to control the subject motion, and they have also proposed a novel latent shift module to govern the camera movement. It shifts the noised latent to move the camera pose. Through quantitative and qualitative experiments, they have demonstrated the superiority and effectiveness of the proposed motion control methods, and they can be applied to different base T2V models without further tuning. So all in all, I think this is quite innovative training-free method for controlling subject and camera motions. It's really a bummer that I don't have the code and weights at the moment, but I believe that as soon as that is released, I think that is going to be a huge big thing, because we can then manipulate the cross attention maps to govern the subject motion, and I believe that is something really cool. And if you go through their paper, they have given a lot of other examples which really I think would be amazing ones. It is in comes into the practice, because MotionBooth fine-tuned the T2V diffusion model to learn specific subjects, and by utilizing subject region loss to focus on the subject area. The training procedure incorporates video preservation data to prevent background degradation. Also, an SDCA loss is designed to connect subject tokens with the cross attention map, and during inference, training free technologies are proposed to control both subject and camera motion. Also, they have done a lot of experimentation, and all of those experiments have demonstrated that the effectiveness and generalization ability of their method is quite spot on. So all in all, in conclusion, in summary, MotionBooth can generate vivid videos with given subjects and controllable subject and camera motion. So that's it, guys. Really amazing stuff. I will drop the link to this project page in video description. Go through it. Let me know what do you think. Also, towards the end, I really want to request you to subscribe to the channel if you haven't already. I'm sure that already most of you already have done it. And the real request is that please share the videos and the channel among your network, on social media, wherever, but whatever social media do you use, even send it in the emails, because that would really help. I'm really looking to count on your support here, and I'm sure you will help me out. Thanks again. Please keep watching and have a good day.